All right, so all right, if I have 332 and base 4. I'm just going to pause for a minute, see if you can figure that out. Sorry. Yeah, please talk to each other.
Just know that you can't lose this because this is from when I was in high school.
Are you talking to me?
Yeah.
What about
You would lose it, but just want you to know it's from when I was in high school.
It's so pretty.
Try, but yes, it is.
And I didn't give it back to you, did
No,
I?
you can use it however much you want.
I'm done. I'll use that one.
No, I leave it on my house. Look, it's from high school. This is from when I put tape, I put little formulas in there. Why not? Well, so one of my students that I tutored in LA, she was like, just a very like nervous testing and stuff, and she didn't have her calculator, so I was like, do you want to use mine from high school? She's like,
Anybody get it?
I
Yeah.
was like, no, you can. And she, it was like this big sentimental thing for her. I was like,
Maybe
of course, like, use
I don't
it.
know
And
the
I said,
way.
you know, you won't lose it. And whatever.
So she goes. Okay. I might have it. 62. Okay. So the answer is 62. Did y'all get that? All right. So what if you have 332? If there's not a base, it's understood to be base 10, right? That's because you have 3 times 100. 3 and the tens unit, and then 2 units, right? Okay, so that's how bases work. You have the units digit, 10 to the 0. You have the tens digit, 10 to the first. You have the hundreds digit, 10 to the second. You have the thousands digit, 10 to the third. Isn't that how our base works? Okay, so if you have 3, 3, 2, then you have 332. Because you have 3 100s, 3 10s, and 2 units. So in base 4, I draw these little boxes like my algebra teacher taught me, because I learned it in algebra, even though we don't do this anymore. I have the units digit. I have 4 to the first and 4 to the second. If I need more, I would have 4 to the third in base 4, okay? So I have 3, 3, 2. So how many 16s do I have? 3, that's 48. How many 3s do I have? 4, that's 12. And then I have 2 more units, that adds up to 62. Okay? Why could I have asked you this? Why can I not ask you that? Okay, in base 4, I can use the digits 0, 1, 2, and 3. In base 10, what digits do you use? 0 through 9. In base 2, what digits do you use? I think a lot of you have just a little bit of working knowledge of the binary of base 2 is the zeros and the ones that computers use, okay? If we did try this, look why we couldn't do it. I think it's probably worth seeing. 4 to the 0, 4 to the first, 4 to the second. So if I have 3 of these and 3 of these, if I have 4 of those, doesn't that bump me over to the next category? Do y'all see what I mean? If I have 4 16s, I have a 64, which would have been the 4 to the third. It would have been the next category. So in base 5, what digits do you use? 0 through 4. And why is there not a base 1? The only digits you would have to use would be 0. Okay? Because base 10, we don't use a 10, do we? If I use a 10, doesn't it knock me into the next category? I have 10 ones, that means I have 1 10. Y'all got that? Okay. So let me give you one more to try. Let's do 512 in base 6. So try that one. Let's just do 12 in base 6. I don't really want to get a lot of... I'll tell you what. Do 52 and base 6. $32. So down here, your units digit is 6 to the 0. Then you have 6 to the first. Next, you would have 6 to the second, and so on. Okay. Are y'all all right? So how I really got the base 10 number of 32, as I said, I had 5 6s plus 2. To get 332, I had 3 of the 4 squares, I had 3 of the 4s, and then I had 2 1s. And I did this one in base 10. So if I have this number going back to our old problem in base B, if you were here or watched the video, we did this last time with that really probably, I can't imagine any of my students would have gotten it without some explanation of what was going on with bases. And this is where we stopped in the last practice, okay? But do y'all understand that would be AB plus A? Okay, because you would have B to the 0, and then you would have B to the first. And if I had a bigger one day that I had to do, you would have like an A times a B squared, an A times a B, and then you're really working in contest math, okay? All right, so I would say that this problem that we're working on is one of the more difficult ones. You needed to know what in the world to do with bases, but then you need a lot of structure. We were given I'm looking for the problem. It was number 2, but I can't find the question for number 2. Where did I put the question? It's probably over there on my desk. Let's see. There it is. Okay. So we had AA base D over AA base C. And I'm guessing most of y'all just like at this juncture before practicing, you probably just skipped it and thought, I hope I can do the next one, okay? So this is what I did the other day, but we've built up to this. This is A, D plus A divided by A, C plus A equals A, B plus A. And so hopefully from practice, if you get a base in the next few years that we're all together, or more in next spring, in the spring, you'll be able to go right to that, okay? Then I had A, D plus A. I could have left it divided, but I just felt more comfortable with multiplication. So I multiplied this to the other side. And then I factored out an A. And then if you were here or watched the video, you heard me start stumbling around with what I was going to do with the A, and I couldn't remember my thought process. When I worked it myself, I was just clocking through, you know, just sort of like math team stuff that I know, and then all of a sudden when I wanted to explain to you what I was thinking, y'all may remember, I was like, so moving on. I couldn't remember why I did it, but I sat down with it this morning and I thought, okay, this is how I'm going to explain to them my thought process. I can only cancel out one of the A's. So I have D plus 1 equals A times B plus 1, C plus 1. Our product is the largest possible sum of B plus C. And right now, I'm going to ignore the fact it says B plus 1 and C plus 1. If I have a number times 2 other numbers, what's the way to make these 2 other numbers the largest if they tell me A is an integer? Make it the smallest. And the smallest integer I could make it would be 1, because they told me that the integers are all, B, C, and D are greater than 1. Oh, it says it's a positive integer. And so, y'all see that's why I let A be 1, because that would drive B and C to be big as they could be. So I'm ignoring A. I'm just letting it be 1. I'm messing around with B and C now. Then you want to, in contest math, you want to just grab the information they gave you. And unfortunately, they said that D is less than or equal to 100. I wish they said less than or equal to 5 or something, okay? So they told me D was less than or equal to 100. Here's a clue as your coach to my math team. Obviously, you're not expected to go from D being 100 all the way down to 1. You're looking for some hope, some pattern as you play around with this. I have a lot of confidence in like, I'm just going to dive in and see what happens. You can always see what happens at 199, and then you may want to flip down into the 50s and then into the 20s and see what's happening. So if D is 100, that'll make this 101 equals B plus 1 and C plus 1 because we're letting A equal 1, so I'm ignoring it, okay? They tell me B and C are integers and 101 is prime. And y'all heard me say that, but I was like in a hurry to finish this problem and had already stumbled through my explanation at this point. So are y'all okay with that? Can't happen. So the next thing I'm going to try to let D be is 99. All right, so I'm going to keep looking back at this green right here with A is 1. All right, if D is 99, then I get 100 equals B plus 1, C plus 1. You're looking for something to organize your information. I could use 4 and 25. And if I found I was scattered, I couldn't get anything. I just found I had to be really structured in this. Sorry, that should be B plus what? 1. Okay, so that means B plus 1 is 4, so what would B be? 3, and C would be 24, and I would add them together for 27. Okay, so I'm sort of investigating right now. I like, in Math Madness, you can skip. And Princeton, if I take you to Princeton next year, your first test will be individual for however long you're in there, an hour and a half or whatever. It's so much fun. I hope you go. But on the first test, you'd have I've forgotten, we'll do practice 7 to 10 individual problems, and you can skip around because you're just trying to get the highest score you can get to the next round. So you would skip this one. So now I'm just playing around with it. And I don't want to use 1 times 100 because then B would be 0. I also don't want to use 2 times 50. Why not?
It'll be 49 and 3.
Okay, well, remember B plus 1 is 2, so what would B be? Base 1, and can we have a base 1? Remember, you got to remember how the question started. B is a base. I can't have base 0. I can't have base 1. So that helps us. We can never have, we're not going to ever have a factor of 2 in our whole list because that would knock me down to a base of 1. Do y'all see that? So that's out. Also, it doesn't add up to enough. It would be 1 and 49. Oh, it would be. So it would add up to 50, right? Which is really actually higher than anything I could find, but this one doesn't make sense in context of the problem. Okay, so keep an eye on your problems. Is there anything else? 4, 25, 10 and 10. All right, you've already gotten that far, so that would be 10 and 10 would be 9 plus 9 is 18. So far this is the highest. Can you think of any other integer factors? Sometimes it's good to do this, 2 times 2 times 5 times 5, so you can look at all the different. 5 times 20. What am I missing here? Oh, wait, hang on. 25 times 4. Now I'm all of a sudden, for 100, you have 4 and 25, 2 and 2, 5 and 5. Oh, 5 times 20, okay. Anyway, Grace, in case you're worried about me, I wasn't worried about if 5 and 20 multiplied to 100. I was just looking at my factors and it wasn't making sense to me. All right, that would give us 4 and 19, which is 23. And so we're thinking real discouraged, okay. Yeah, I don't want to do this anymore. So let's go to 98. And you'll find as we work together more that you will start to notice patterns, okay? So that would make this 99, which you can wish me a lot more with my factors. So we have 3 and 3 and 11, right? Okay. So Grace is going to start with, she said 3 times 33, which gives me a base 2 and a base 32. 34 right now is my highest.
6 and 11. No, that's lower. That's
9 and 11? 9 and 11, but that gives me 8 and 10. 18. Is there anything else? Okay, so that went a little faster. So far 30. Are we okay? All right, if D is 97, I would have 98. 98 is 2 times 49. Are we going to use any 2s? That knocks me down to base 1, so I can move a little faster. The only integral factors of this are 7 and 14, which knocks me down to 6 and 13, which is 19.
For the 99,
Did I miss a 99?
well, you said 2 plus 32 is 34, but you can't use 2.
Oh, I used 3, which knocked me down to base 2. So 3 is, we were doing B plus 1 and C plus 1, which I quit writing, but, so I'm saying B plus 1 is 3, so my base could be 2. I just can't have B plus 1 be I can't have a 2 in this position as a factor before I subtract 1 and get my addition, okay? I think that's all for 98. If D is 96, then that's 97, and Alice is our prime person. Is 97 prime? 97's prime. She's going to fill us in on that later. She just knows. She's going to tell you. I'll have Alice teach us about primes later. All right, D is 95. So that would give me 96. 96 is 2 times what? 48. So that's 2 times 2 times 24. 2 times 2 times 4 times 6, and maybe we can manage it with this. I don't want any 2s, so I don't want 2 times 48. So I could do like 4 times 24. That gives me a 3 and a 23. Well, that's not higher than 34. Did I do something wrong?
Yeah, 32.
What's 32?
Free 23 is free 32. Oh, right.
I don't know what we're talking about. Start over.
You did 3 and 23, but it should be. Wait, no. That's correct.
Wait, time out.
No, it's right. You're right.
I don't know what's happening. So on the front row, what were you saying? Like these two girls?
You know how you got like 4 and 24 underneath it's free and 23?
Yeah.
Because this is B plus 1 and C plus 1.
Oh, I thought you were
Yeah,
talking
so
about
using 3 times.
I thought you were talking about another factor.
Okay. No, I was like doing the underneath to see if I get more than 34. Right now, 34 is the winner. Grace?
Okay, so what I was thinking is that, so it seems that the ones that always produce the highest numbers at the end are the factors where there's one really small factor and one really big factor.
That's what you're looking for.
And
Do y'all see what she's saying?
the smallest small factor you can have is 3, because then that's reduced to 2. And so 3 times
Exactly.
the highest number possible, and so that would be 33.
Exactly.
Because there's no number, like we can't, the only other ones are 101 and 100, and those can't be divided by 3.
Exactly. That's why you're sitting here. Thank you so much. Okay? They have like this whole paragraph. Like, at first I looked at their solution and I thought, I'm not even going to read this. Then when I read it, I'm like, I don't get what they were doing. So I just sat down and listed this. And eventually, if you read it after playing around with it yourself, which is kind of unusual for me. Usually I don't read a solution beforehand, but I was just curious on this one. And they've got this horrible paragraph that you wouldn't want to read. It sounds like it's in a different language. But they get down to the last sentence. Thus, we only need to check values of D plus 1 that are multiples of 3. Since those are decreasing, we can be confident the largest possible value is 34. And so what happened is way up here, so what she's realized is this spread is going to give me the highest sum. And it would only occur with a multiple of 3 because we can't have a 1 or a 2. So the lowest one we want to make this low to make this high, okay? And so then we're looking for multiples of 3, and that would give us the biggest multiples of 3, right? Y'all see that? Great. I didn't know when someone would notice that. I don't know when I was going to notice it. But, and so I was just going to keep writing until something happened because I already knew the answer. But, so the answer is 34. It was not going to get any higher after that, okay? All right, so there that is. At least we got in bases. Now let's go to the probability problem. That Mr. Hill gave me some really good insight on that one. Probability. Before we do probability, it's probably good to review when I'm giving you new concepts like I started with basis today. If I have the greatest integer function, and where?
One of the coding classes.
Oh,
And we did this. It's so stupid.
So if you have 1.8, that would equal 1. Okay? That's how it's existed for centuries. This little notation means pick an integer and don't go over. That's why it's called the greatest integer function. If I have enough money to buy, I was talking to some people about buying tickets to the Rockettes, okay? And if I have enough money to buy 3.8 tickets, I'm not going to go online and buy 3.8 tickets. I can only buy 3. Are y'all okay? Y'all are talking, which is great. Math team does that. Their minds are racing. Do I need to? Okay. So what I was getting to. This, that equals that.
You just round down for it.
The floor function and the greatest integer function are the same thing. They're synonymous. If I want you to round up,
The floor function is
you do the ceiling function.
so that would be 2.
That would mean I've calculated I need,
It's like a ceiling.
I might need 1.8 volunteers for something, and I'm getting, I may like say for a field trip, we have to do this. Say we need an adult for every 8 students, and I divide, and I need 1.8 adults. I'm going to have to get 2 adults to go with me. I couldn't just take 1. I wouldn't have enough. And so this has meant this for centuries, but then this has become a little more acceptable. On your computer and on your calculator, if you use INT for integer, it will do the floor. If you want to force it to do the ceiling, you would type in INT plus 1. In case you're ever programming. Okay. And so let's move on to this team thing. If you started listing these, it was a nightmare. And, I'm a big fan of listing things and looking for a pattern. And so if some of y'all got this one right, you can talk about how you did it. There are 6 teams invited to a state high school championship basketball tournament.
I really thought I was going to get it right.
And the first round will feature 3 games. I'm always writing as I'm reading, so here's the gym, and there's 3 courts. One of them's not really smaller than the other one. I'm sure they're all the same size. 3 games played simultaneous on 3 courts, pairing the teams at random. 3 of the teams are from Circleton. The remaining 3 teams are from different cities. So let's call it Circleton 1, Circleton 2, Circleton 3, and then maybe X, Y, and Z. You probably did something similar trying to make your list. The probability that 2 teams from Circleton will not be paired against each other in the first round can be written in lowest terms, A over B. So before we even answer the question, be sure you answer the question. Eventually they want me to say what A plus B is. But they want the probability that they will not be paired with each other. The answer, you may not know the answer, so somebody may want to give us some input. The answer is 7. You might get 7? What'd you do? Do you remember? Is it?
I think I did like the first one. There's 2 rounds. There's first round.
Here, do you want to come right? Here we go.
Can I answer the question? Okay, I don't remember it very well.
Here you go. It's right here. So it starts with 6 teams are invited, but all the body of information's right there. And I didn't do what they did, so I wouldn't even read that. Sorry, I'm putting you on the spot.
So
Okay, listen up, girls, because probability is a big part of this.
so the
And working them fast and easy is what we're looking for. Okay, go.
there's 2 people in the round. So then in the first round, the probability of choosing one of the team, like any team, is 6/6, because that's like any team that you can choose from. But then in the second round, it's. Hang on, I'm trying to remember what I did.
You probably did,
It's.
who's playing in this court? Is that what you mean?
It's. Did I do that?
I don't know, keep going.
I
I
think-
guess. Now you know how I feel when I start.
Hang on. Because I remember I did that times whatever this was. Which is. I definitely did not get this. This is not the right number.
That's not what you did, because.
No, it was something over 5 though, I'm pretty sure, because you remove one team because one team is chosen for the first round, and then
Well, and your 6/6 is a 1,
right.
and so you must have multiplied wrong or something, because 2/5 does equal.
Oh no, it was 2/5.
Yeah. Did you just have 2/5 written there?
Yeah.
So when you multiplied 6/6 times 2/5, you should have gotten 2/5. You
Yeah.
got 12/30, and you just took 2/5. Yeah.
Okay.
You just were.
Yeah, I was
nervous.
just.
Yeah.
Yeah.
However, do you see you did that? Kind of a circular
Yeah.
way of doing it, because that was just 1. Okay.
Mhm.
All right. So now that she's thought about it, do you want to explain it a little bit
Yeah,
more?
so
Okay,
then-
here we go.
The second number, you remove one team because one team's already playing, and basically you assume that one Circleton team is that team that's like that was played.
Okay, we have
Sorry,
6
this one.
teams. And so I think these numbers are she's pairing them into a quarter. Okay, so it's maybe her first round. I think that's team 1 and team 2.
Right, and I.
So when I pick a team to play, I go, okay, I got Marymount, Chapin, Brearley, Nightingale. Any of those 6 teams can take one of those 6 places.
Right,
Okay.
and then the second number is you remove a team, and then I also removed a team from Circleton. I'm pretty sure.
You did.
Yeah.
Because that's the only way to get it. I was looking for my notes.
But I assumed that the team that was chosen was from Circleton. No, that wasn't from Circle. Wait.
But if you assume the second number, if you assume the second team like can't be Circleton because the first team is Circleton, would that be like against 6?
I feel like it's got a different number.
Is there
I don't
a
remember
difference?
6 or 5 very well.
I think that's what we got.
It's like, if the situation's like assuming that the first team is Circleton, that'd be 3 out of 6.
Oh no, yeah.
And then the next number would
Hey,
be.
Mr. Hall, do you feel, will you do the team problem? The way that you talked me through it? Will you jump in? All right, I'm gonna let Mr. Hill show you what the way he worked it. It's pretty much what Susie did. So before he starts, when you're doing probability, which you've all hopefully done in class a little bit, if I say, what's a probability I'm gonna draw 2 aces out of a deck of cards, you actually act like your first one's an ace. That's how you get the probability. Oh yeah, I'm so glad I asked you because he's going to show you the teams. But anyway, you got to start like that it is happening to you. Do y'all see what I mean? Before he goes, I'm sorry, I got him to stop. If I'm going to go the probability, I'm going to draw 2 aces. It would be 4 out of 52. But if I'm holding one of those aces in my hand, what's the probability the next one's going to be an ace? 3 out of 51. Because I already have one in my hand. So you're acting like it does happen to you, and all the other ways it wouldn't.
What was the question?
Okay, here you go. It's the Circleton teams. There's 3 teams from Circleton, and they don't want to be paired with each other.
Okay.
And we have these other teams, X, Y, and Z.
Okay.
So what's the probability that
But they don't get paired with each other.
they don't get paired with each other? Y'all okay with that? Alright, so watch what he's gonna do. Get what you can see.
The circleton teams are the white ones and these are the other teams. So we don't want them to get paired with each other. So there's going to be, if we imagine picking the two circleton teams, we need to pick them, and we need to pick partners for them at random. Okay, well we need to pick one of them and have them not get paired up with the circleton, and then we need to pick another one and have that one not get paired up with the circleton, and they both have to happen. Because then there's only one team left, and this can't be paired up with the circleton because they're already paired. So we just take the first one, okay, here's the first circleton team. How many teams are there that this team could be paired up with? 5. How many of them are the ones we don't want? 2. So there's a 2 in 5 chance that we're going to get a bad result, which means there's a 3 in 5 chance we'll get a good result. Yes? So that's the first thing that has to happen. So that has to happen, and the second thing has to happen. So if the first thing happens, which is a 3 in 5 chance, now we have the second thing. So the second thing is I pick one of these circle teams has to be paired up with somebody. There's 3 teams remaining. How many of them are the ones we're hoping for? 2. So there's a 2 in 3 chance that we get the result we're hoping for in the second one. Okay? So this one has to happen, and the second one has to happen. Okay, so it's 3/5 times 2/3. And in some sense, you can think of that as, for those of you who know about independence, once the first thing has happened, it no longer has any influence on the second thing. And so, as long as we analyze the second thing properly, we can get the probability of both of them happening by just multiplying their individual probabilities.
Okay, and I was doing it much harder. I was trying a combination of 6 things, 2 at a time, and I got like 90 ways to, somebody else may have gotten that number, I got like 90 ways to put the teams together. And Mr. Hill's kind of my go-to probability person. So
You were right about 2/5. You
Yes.
just got
I
it
don't understand.
I like the, I think she did it right though. She did,
I didn't see
Mr.
what she did.
She picked the first round though,
Okay.
but she also doesn't remember what she did.
Because I remember.
She did something like 6/6 and then 2/5. So she said
Okay, that's fine.
she could pick any of the 6 out
So
of the
there's a 100%
6.
chance of picking your first team.
But then, once she gets one of them, if it's Circleton,
Yes. So what you're doing, Susie, is you're saying, all right, I have to pick a team. My first team, well, there's 6 to choose from. It could be any of the 6 of them. So there's a 100% chance that I'll be able to pick a team. That's what the 6/6 stands for. So that has to happen, and I need to pick a second team. Now, this, if I want the result that I'm hoping for, there's a 3 in 5 chance that I'll get a result where Circleton's not paired up with Circleton, and a 2 in 5 chance that I'll get a bad result. That's just the first choice, though. The 6/6 times, if we say we're getting what we want, is times 3/5, right?
it'd be 3/5. It wouldn't be
Yeah,
2/5.
That's the first choice.
Yeah.
But once that choice is done, now we have a second choice to make for the next Circleton team to be chosen.
So
So-
that would be,
So those guys are out of the way. So now there's 4 teams left. So thinking of it the way Susie was going, we do 4/4 times, what is it, 2/3?
so then you would have 3/5 times 2/3.
Yeah. Only
Anyway.
instead of doing 6/6 and 4/4, I'd say if we want to pick a Circleton team, I'd say there's 3 to choose from. There's 3, so that would be 3/3, and then this one would be
Yeah.
2/2 times 2. Where's the other one?
Wait, I think I did do
Oh, is it 2/3? Yeah.
Because you got all of these teams left, then you pick one of these,
Yeah.
and you've got 2 out of 3 that are acceptable.
The problem with probabilities, there's like 9 million different ways to do the problem correctly. So you might be thinking about it the right way that will work.
And then listen to someone else is
Yeah.
kind of difficult.
That's just the way I thought of it.
Yeah, it made great sense to me, and then we got out the little beads and, stuff like that. So let's look at it one more time, because I think probability is going to come up a lot. So let's talk about what has to happen. And let's pretend like, and if you think about it, good grief. I mean, all this math madness brackets that I look at all the time, or if you get down to, if you hear of people betting on like the March Madness, who's going to win.
I just made that connection.
the odds that could happen, I mean, because the permutations and combinations really are just astronomical, that you could actually get down to the winner of the, I think you can win lots of money if you actually pick usually people have like little betting things like at their place of work or for a fundraiser or something where you donate money. Like if we had a Math Madness game that we were going to do with our math team, hoping that we know more than a lot of people, and we're just going to try to pick the winning team. And if you all pay $20 to play, then the winner would get the sum total of that. So that's why people do it. So anyway, so back to what we were doing here. I think I just erased it. So I've forgotten what Mr. Hill's first fraction was. When he put out the 6 teams, fifths and then 2/3. So what did he do? I thought it hard for me to explain what someone else does.
Because he chose like one of the circleton teams first, so then that would have been like 3 out of 3. So, and then that's just like leaves it as 3 points because 3 out of 3 is 1. And then after, like for the second round, it would have been 2 out of 2 times 2 out of 5.
No, it was 2 out of 3 because the 3s have to
Yeah, sorry,
cancel.
that's what I meant.
I did it a different way. Now I'm trying to remember what I did. After I quit doing the combination way, I did it sort of like the aces. Like if I pick a Carrollton team, okay. Somebody was saying Miss Lazari.
So,
Go ahead, Sophie.
well, this is
Did you think of it a different way?
Well, no, it was like afterwards I realized.
Say it again.
No, just like afterwards I realized like how the fractions were.
So you're okay? I thought you were just going to tell us a different thing. Anybody have any other comments on this problem? We will revisit it. I'm always brainstorming of different ways to do things and the easiest way to see it. Susie, did you get that one right that day?
Yeah.
Good.
I wish I didn't recycle that paper.
Yeah. From now on, I need just a little box where you throw our stuff in there because I'm the same way. I need to get a place that we're going to just put our scrap paper and keep for a while or circle it. Yeah. Okay, there was one at the end that I think a lot of you, I don't know if we worked it or not. I didn't do it like they did it. I worked it and then I looked at their example and I'm like, why would you do all that? Let's look at the geometry one. Because we also obviously want to get geometry questions right. So the geometry question, they gave you this. They said triangle ABC has a right angle at angle B. And then they gave you BD and DE.
This one actually, like, I thought I way overthought it, and then at the end I was like, oh.
Do you remember what you did?
Yeah.
Okay, so let me write down what we have. We have BC is greater than AB. Points D and E are located on AC and BC so that AB equals BD equals DE equals EC. I didn't draw that very well. And we want the angle measure of BDE. So I was looking for this. All right, Cecilia, do you want to talk about it? You can write on it. Are you all right while you motion?
Okay.
Okay. All right, so this is how Cecilia, she overthought it, and then I think you saw an easier way?
Yeah.
Okay.
So this angle, and this angle are equal 180.
I'm being like not geometrically correct, but in math team, I'm kind of going fast. I should have called that angle ABC and stuff, okay? And use my little measure symbol. So we're gonna get over that, okay? All right, go ahead.
Since these two triangles are isosceles, then this angle is a angle.
All right, so these angles, these green angles are equal,
This is
and these blue angles are equal. Is that what you're saying, Cecilia?
yeah.
Okay, do y'all see what she's saying? So you should always, when a geometry teacher gives you isosceles triangles, you know the opposite angles are equal, okay?
And then since these three angles equal 180, then if you were to subtract those two, then this angle and this angle would be equal. So x equals 180.
Okay, say that again. I did it a different way.
Since like the blue, the red, and the green equals 180, then if you have
Oh,
the
this
green
right
and the
here?
blue, then this angle has to be
Oh, then you have a green and a blue and a red. So x had to be 90. I love that. That's great.
I like when I first
Yeah.
tried to solve that, I was in through numbers and stuff like that, and it didn't help.
Yeah,
Paper's so messy.
their explanation just went on and on and on. And I'm just like, seriously? Like, did you really do all that? I can't find it now, but anyway, you're confused on what it was asking.
Cause no, I got the question right,
Uh-huh.
but like it was like in degrees of like DBG or something like that. Like
It says, what is the angle measure in degrees of angle BDE? Because there is a way to measure in radians that half the people in
oh,
radian or more.
I originally
Y'all are in pre-cal, aren't you? So it said, what is the angle measure in degrees of angle BDE?
okay. For some reason I thought it was asking like in like if like an angle is like 45 degrees, how many degrees of 45 is that measurement? If that makes any sense.
So you were over.
Yeah.
Oh, I understand.
Y'all, I love what Cecilia did. Again, that's why you're sitting here. I just see such a different thought process. How it'd also be great if we could color code them like that, because it was good that she could go green, red, blue, green, blue, had to be red. I did it with a straight angle along her lines. I said I liked yours better. That's why I like to listen to y'all. And I always pull other people in because I'm just the coach, but coaches have like lots of other coaches working for them. So you have, they usually are just the coordinator of everything. These three equal 180, but don't these three have to equal 180? And so you can do like, you can do it that way also. Comment, Grace, questions?
Oh, I was gonna say I didn't know how to do it, and it was like the end of the time, so I just guessed 90 to
Heck yeah, maybe you'll be right. Especially if they're drawn to scale. Sometimes you can do this, like wedge a 90-degree angle up in there. If they tell you it's drawn to scale, or if they say it's not drawn to scale. You can do that on SATs also. You should certainly guess what it looks like if it's drawn to scale. Okay, we'll stop for now.